Okay, so let's try some more challenging examples. This one here, I don't like the way that the function is written because I'm not able to easily take the derivative. So let's change the form of the function. F of x is equal to x to the negative 1 plus x plus 1. Take the derivative. That's minus x to the minus 2 plus 1. Take the second derivative, which is 2x to the negative 3. Another way to say that is 2 over x cubed. You'll notice that there's now no x in the numerator, so there's nothing that that's going to give me. But the denominator can't equal something. X cubed can't equal 0. That means x can't be 0. So I know that when I make my table, at 0, it's going to be undefined. Over here, I'm going to get 2 over x cubed. I'm going to pick a number less than 0. So that's a negative number. Sub it in. I get negative. Pick a number bigger than 0, and I'll get positive. This means that it's concave down and then concave up. The question looks really challenging, and there's definitely more to it when drawing it. So if I was to actually show you what the graph looked like, that's what it's actually going to look like. Notice that this portion of the graph is concave down, and that this portion of the graph is concave up. Notice that there is an asymptote here at 0. It is undefined at 0. Last example, I suggest that you try this one on your own first, and then come back and check your work. I don't like the way that this is written again, so I'm going to change it, and I'm going to say f of x is equal to x squared minus 4 to the negative 1. This enables me to use the chain rule, which is what I'm going to want to do. If you haven't already noticed, I'm going to point it out, that there's something about the domain here already. X cannot equal positive or negative 2. Hopefully in your work you'll notice that this is the same and that this will continue to be true. Everybody take the first derivative. Once you're done with that, take the second derivative. Be sure to check your work. When you take the first derivative, you're going to be using the chain rule. Notice that I get minus 2x over x squared minus 4 all squared. It's at this point when taking the second derivative that you have to choose. Will you leave it as it is in the form that it is on the page right now and use the quotient rule? To take the second derivative, or will you change the form into the following and use the product rule? You decide whichever you'd like to do. It doesn't matter to me. At the end, your answer will be the same. So pick which rule you're going to use and which form you're going to use it in. I suggest making a table and then taking your second derivative. Give that a shot. So I decided to use the quotient rule myself. I got to here, and in doing so I noticed that when I take out a common factor I can reduce slightly. When I do that and I collect like terms inside the bracket, I get minus 2x squared plus 8 plus 8x squared all over x squared minus 4 to the 3, which leaves me with 6x squared plus 8 all over x squared minus 4 to the 3. Well, now I want to check and see where I get my possible points of inflection or my areas at which the function does not exist. So I set my numerator, 6x squared plus 8 equal to 0. That gives me 6x squared is equal to negative 8. Well, that never happens, so this doesn't provide me with any points of inflection. I know that x squared minus 4 can't be 0, because otherwise this wouldn't work. So x squared can't be 4. That means x can't be plus or minus 2. Hey, I already knew that. They told me that at the beginning of this question. So I've actually just verified what I knew at the beginning. I'm going to make my sign table. Negative 2 and positive 2 go on it. 6x squared plus 8 and x squared minus 4 all cubed. I'm going to pick a number less than negative 2, and that's going to give me positive and positive. I'm going to pick a number in between negative 2 and 2. 0 is the best. That's positive and positive. And I'm going to pick, that's negative. Positive and negative. I'm going to pick a number greater than 2, so let's say 5. That's positive, and that's positive as well. A positive and a positive make a positive. A positive and a negative make a negative, and a positive make a positive. Well, I already know this to be true. It is undefined here, and it is undefined here. So I have no points of inflection, but I do have differences in concavity. It's concave up, concave down, and concave up again. That's about it for today. Homework will be posted on Blackboard, so please make sure that you go there and actually give the homework a try. If you have any difficulty, please come in and see me. Make sure, because we're going to be building on the topics that we've learned today and the information that we've learned today in the next few classes, and that will definitely lead up to the test, which is in a few days. Thanks so much, everyone.